For this video, I want to talk a little bit about writing equations for parallel and perpendicular lines. Okay, so to learn what we're dealing with here, let's consider a line of the form y equals mx plus b. Okay, a line parallel to this line is going to have the same slope. Okay, to see why this is, just think of if we were to draw a line that looks about like this. A line that is parallel to this line is going to look about like this. Okay, it's going to have the same rate of change for this line. It's they're never going to touch. If they had a different slope, or one was increasing faster, or one was increasing slower, if we went off to infinity or off to negative infinity, they would cross each other and therefore not be parallel. Okay, a perpendicular line will look a little bit like this. So it is going directly at a 90-degree angle through that line. Okay, so that is what that's going to look like. So let's talk about the basic properties here. So here we have a parallel line. We'll have the same slope, but it may have a different y-intercept. So it's going to have the form y equals mx plus c, and c, where c uh, is not equal to b, or it may not be. I guess I should rewrite that. Where c may not be equal to b. Okay, so that is going to be the form of a parallel line. A perpendicular line, again, where it forms a 90-degree angle with our line, that is going to be of the form y is equal to negative 1 over m x plus b. So the idea is you take the inverse of uh, um, of your slope and you make it negative, and that's going to be your new slope. Okay, so you flip your slope, make it negative. That's your new slope. Okay, um, so that's the structure for the equation. It may have the same y-intercept. That's possible, but we'll just say we'll use a different letter. Actually, we'll call it plus d. We don't know what that's necessarily going to be. Okay, so let's go through a couple examples here. So we want to consider the line y equals 9x minus 9. And first we want to find a line that is parallel to this line, which passes through the point 2, 3. So a line that is parallel, so let's start with A here. A line that is parallel to this line is going to be of the form y equals 9x plus b. Okay, and we don't know what b is, but we know it's going to have the same slope because it's parallel. But we do know that it passes through the point 2, 3. So to find out what b is, let's use this point 2, 3. So we can say that 3, upon plugging in the point 2, 3, 3 is equal to 9 times 2 plus b. Or we have 3 is equal to 18 plus b. We can take 18 away from both sides, and we'll get that b is equal to negative 15. Therefore, a line that is parallel to this line and passes through the point 2, 3 is going to be in the form y equals 9x minus 15. Okay, so this line will be parallel. It passes through the point 2, 3, and yeah, so that is our parallel line. Let's take a look at a perpendicular line. Okay, so because we want to find a perpendicular slope, remember, perpendicular slope is of the form negative 1 over m. Okay, so we can write this as so that means our new line is going to be y equals negative 1 over 9 x plus b, and we don't know what b is, but we do know that it passes through the point 2, 3 again. So let's go ahead and plug that in to find out what our b value is. So we'll have 3 is equal to negative 1 over 9 times 2 plus b. All right, so we have 3 is equal to negative 2 over 9 plus b. We can add 2 over 9 to both sides. And we'll get that b is equal to 3 plus 2/9. Okay, but we need to write 3 so that it has a denominator of 9. All right, so we can write this as b is equal to 27 over 9 plus 2 over 9. Or, in other words, we have b is equal to 29 over 9. And I think that's about as simple as it's going to get. So that means the equation for a line that is perpendicular to our initial line is going to be y equals negative 1 over 9x plus 29 over 9. So there we go. Now let's look at this one. Let's consider the line y equals 3/4 x minus 1. And the first part is we want to find a line that is parallel to this line and passes through the point 8, negative 3. Okay, so when we flip the slope, well, I guess we'll get to that in part B. We'll explain this here in just a second. Let's do part A. Part A is the same as before. So we know a line that is parallel is going to be of the form y equals 3/4 x plus b. All right. So we can take the given point that this line is going to pass through in order to find out what our y-intercept is going to be. So we have 8, negative 3. So we know that negative 3 is going to be equal to 3 over 4 times 8 plus b. And now we just solve for b. So we have negative 3. Negative 3 is equal to 24 over 4 plus b. Or negative 3 is equal to 6 plus b. We can take 6 away from both sides, and we have that b is equal to negative 9. So the equation for a line that is parallel to 3 over 4x minus 1 and passes through the point 8, negative 3 is going to be y is equal to 3/4 x minus 9. Okay, so for part B, this is where it gets a little more interesting. So we need to flip the slope and make it negative. So if you want to take 1 over 3/4, this is the same thing as just saying 4 over 3. So we flip the slope. So instead of just saying instead of having 3/4, we're going to have negative 4/3. So we flip the slope, make it negative. So a line that is perpendicular will be of the form y equals negative 4/3 x plus b. And we don't know what b is, but we know that it passes through, again, the point 8, negative 3. So we can use this to solve for b. So we have negative 3 is equal to negative 4/3, 8, yeah, times 8 plus b. So we have negative 3 is equal to negative 32 over 3 plus b. Okay, so we can add 32 over 3 to both sides. Okay, so cancel, and we have that b is equal to negative 3 plus 32 over 3. But we can write negative 3 as negative 9 over 3. Okay, so when we add 32 over there, again, we do this because we want to find a common denominator. So now we can add 32 over 3 to negative 9 over 3. And that's going to give us 23 over 3. And we can't simplify that anymore. So we have y is equal to negative 4/3 x plus 23 over 3. So this would be an equation of a line that is perpendicular to the given line.